So this is CCNA troubleshooting lab number 1. Once again, if you're following along with this, or if you're doing this on I&E's CCNA racks, one thing I would definitely recommend is before you do this first lab, write erase all of your devices and reload them. Set them all back to factory default, then load the working configs and move on from there. You won't have to do that after this first lab, but definitely for the first lab, if you already built up the monster lab that I call it before this, you want to clean all that stuff out and then put the OSPF working configs onto this. Now as we move forward, for example, when you're done with this and we move into lab 2 or lab 3 or something, just as an example, if you finish lab number 1 and you realize that the only device you actually changed in any way, let's just pick one at random here. Let's say it was router 1. Let's say router 1 was the one that you actually fixed. That's the one that had the problem on it. Well, now when you move into the next lab, like lab 2 or lab 3, you don't have to load the OSPF working config on all 7 devices because you never touched the other 6 of them. Just load the working config on the one that you fixed in the last lab, the one that you changed, and that'll save you a lot of time as well. So here's our problem description. R2 cannot ping the loopback 2 of R3. Let's verify that that actually is true. So here I am on R2, loopback 2 of R3, which is 3331. Okay, yes, I cannot ping it. It's not working. Lab restrictions. No changes to the physical layer topology are allowed. The reason why it says that is because in some of these labs, interfaces might be administratively down, and that is intentional. Or maybe interfaces are up that you did not expect. That is intentional. So you are not allowed to shut down or do a no-shut on an interface unless the lab actually tells you to do that. In this case, we're not being told we can do that. Any existing access lists may not be deleted. However, individual access control entries may be deleted or changed. IP access group commands may not be modified or removed from an interface. You must ensure that the finished working lab adheres to the original lab specifications. That's sort of like a catch-all phrase saying, look, you can't just decide, oh, to fix this, I'm just going to wipe out OSPF and configure RIP instead. Or I'm going to change my IP addressing plan. Big dramatic changes like that as simple workarounds you can't do. Basically just think to yourself, okay, if this is a live production environment, is the change I'm thinking of doing something that would be impacting a lot of people negatively possibly? Then if that's the case, don't do it. Okay, so we know that we can't ping the loopback of router 3. So the way I'm going to go through these labs is when it comes to troubleshooting, there's a lot of different ways to troubleshoot something. There's no one correct way. Just like there's a lot of incorrect ways to troubleshooting. For example, if I can't ping, if I all of a sudden throw up my hands in despair and say, oh, the sky is falling, the sky is falling. Well, yeah, that's probably the wrong way to troubleshoot it. Or if I go to my manager and say, I think the network is dead. Also, probably the wrong way to troubleshoot it. But similarly, there's more than one right way to troubleshoot it. So I'm just going to go through this using the thought process I would use, which may be different than the way you used, but hopefully you can gain some insight from it. Okay, so let's expand this a little bit. So we already know that I can't ping. So the very first thing I would check would be to see if I even have a route to this. I would check my layer 3 routing table. Show IP route 3331. Okay, no network in table. Now I know that, I'm coming to this topology and I know that I'm supposed to have a route and it's supposed to be OSPF. This is working, this is based on the monster config we just finished. Everything was functional via OSPF. So now I have to wonder, okay, where are my OSPF routes? Do I have any other ones? Any other OSPF routes? No. Well, I got a couple here. I've only got 2 OSPF routes, but where are all the other ones? Okay, the next thing I would look at is I'd say, okay, Do I have all the OSPF neighbors I'm supposed to have? Am I communicating with who I'm supposed to be communicating with? Show IP OSPF neighbor. So looking at this, so it says my neighbor, I do have two neighbors in the full state. That's good. I have a neighbor on 00.3 and 00.2. Okay, well, let's just go down that trail. Now, I remember from the previous lab that I should have had also a neighbor on Fast Ethernet 01, and I don't see that. But that's not necessarily critical to be able to ping here. I mean, at a very minimum, one neighbor should be giving me the route. Now, yeah, I probably want to troubleshoot at some point why I'm missing the third neighbor, but at least one of these guys should have sent me the route to that network. So let me troubleshoot and figure out what's going on with them. Okay, so let's now go to, let's see here, .46 and .42. That is switch 3. So let me jump over to switch 3. And first of all, let me see, can I even ping? Let's just jump over to switch 3. Same thing, show IP route 3331. Network not in table. Okay, who does he have as OSPF neighbors? Okay, so he's got neighbors on VLANs 1, 2, 3, and 6. So if I look at my topology diagram right here, switch 3, 1, 2, 3, and 6. So he's got a neighbor right here. So there's a neighbor on that interface. Neighbor on VLAN 2. So he's got a neighbor right there. He's got a neighbor right here, VLAN 3. And he's got a neighbor right here, VLAN 6. But we've been trying to ping this network right here. And looking at our topology diagram, the only one that could possibly advertise that network to him is router 4. And we don't have router 4 as a neighbor. Okay, what about switch 2? Does switch 2 have router 4 as a neighbor? Let's find out. Okay, so once again, switch 2 does not have router 4 as a neighbor. So router 4 is cut off from our topology. That's why we haven't learned of any routes to that loopback. So now we've isolated our problem here. We know, looking at our topology diagram, we have to troubleshoot why there's no neighbor relationship with router 4. So we could take this from one of two standpoints. We could either troubleshoot why switch 2 doesn't have a neighbor relationship, and or why switch 3 doesn't have a neighbor relationship. Okay, so let's start with switch 2. Just randomly, let's just pick him and figure out why he does not have an OSPF neighbor relationship with router 4. So switch 2. So if I don't have a neighbor relationship, the next thing that would come to my mind is, okay, well, in order for a neighbor relationship to even form in the first place, OSPF would have to be active on this interface, right? OSPF would have to be active on SVI 5 because router 4 is also in VLAN 5. At least I assume it is. It's supposed to be. So let's see if OSPF is indeed active on interface VLAN 5. Show IP OSPF interface brief. Okay, it is. It is active. All right, and it says, oh, it looks like I used to have a neighbor. And the neighbor's down. Okay, but at least I know that interface VLAN 5 is covered by an OSPF statement. It's not a missing or incorrect network statement of some kind. All right, so further troubleshooting. Let's go ahead and take a look at interface VLAN 5 and the configuration and see if we can spot anything that might be in there that prevented our neighbor relationship. Show run interface VLAN 5. Okay, and at this point, what I'm going to do is I'm going to open up a second connection so I can compare router 4 and who his neighbors are at the same time. Okay, so interface VLAN 5. So looking at our topology diagram once again, what I need to focus in on router 4 is if I'm concerned with the neighbor relationship between switch 2 and router 4, then I'm talking about this right here. So I want to look at his fast Ethernet 01. Show run interface fast Ethernet 01. Okay, let's just compare some basic stuff. Are they in the same subnet? Yes, they are in the same subnet. Okay, they're using authentication. Is it the same kind of authentication? Yes, it is. Are they using the same password? Yes, they are. Is either one of these interfaces shut down? No, it's not. Okay, so there's nothing at the interface level that would cause me to not have a neighbor relationship. Okay, so the next thing I would check, so at layer 3, let's just check router 4 and let's look at his OSPF process. Let's do show IP OSPF interface brief because we did not check yet on router 4 to see if OSPF was working on his fast Ethernet 0/1. Let's expand this just a little bit so it's a little bit clearer. Okay, it is fast Ethernet 0/1. It is covered on there. It says it's in area 0 over here. VLAN 5 was in area 0, so they're in the same area. Okay, no problem there. Let's look at our running config now and go down to our OSPF process and see if we can spot anything that would explain the lack of relationship between these two. All right, so there is our process on switch 2, show run section OSPF. Okay, and let's just line these up here. Okay, so here we go. So we already know that we've got the correct network statements because otherwise it wouldn't show up in the interface in the first place. So I don't see any other funky, weird commands here in the OSPF process that would prevent them from talking. Similarly, if I go back to my interface, show run interface fast Ethernet 0/1. Oh, wrong guy. Show run interface VLAN 5. Okay, I don't see any access lists or anything here preventing them talking. On router 4 side, show run interface fast Ethernet 0/1. Don't see any access lists here preventing them from talking. So from a layer 3 perspective, everything looks great. I don't see any problems here with the OSPF configuration or with the IP configuration. So now at this point, I would have to check off layer 3 and I would decide to start moving down the OSI stack. So let's move down to layer 2 now and check that out. So while we're on router 4 here, let's just take a look at his interface. Show interface fast Ethernet 0/1. Let's try that again. Okay, it says it's up. Line protocol is up. Looks good. Okay, we got full duplex, 100 megabits per second. All right, now let's go ahead and from a layer 2 perspective, there's really not much else we can check on router 4. So now let's check on the switch, his layer 2. So layer 2 would mean checking the VLANs and the VLAN to port assignments. So it's supposed to be in VLAN 5, so we got interface VLAN 5. So let's check now on switch 2 what kind of VLANs we have. Let's do that again so it's a little bit easier to see. Do you see something missing? Where's VLAN 5? If we go back to our diagram right here, actually let's go back to this diagram. If you recall, this whole section right here and all these interfaces are supposed to be in the broadcast domain known as VLAN 5. And we don't see VLAN 5 here. VLAN 5 does not exist in my output. Let's check the configuration of the actual physical port that's connecting switch 2 to router 4. And checking my configuration here, that is port 0/4. Show run interface fast Ethernet 0/4. Well, I think we've identified at least one problem. The interface is correctly configured to be in VLAN 5. It is an access port, but VLAN 5 does not actually exist. That's going to be a problem. Furthermore, if I do show interface fast Ethernet 0/4 switch port, look at this. Access mode VLAN inactive. So this port is in a VLAN that does not exist. And when that happens, the port might as well not even be there. It's not functional at all. All right, so let's see if we can fix this. The port's already in the correct VLAN. The VLAN doesn't exist. So all we need to do at this point is create the VLAN. And let's see if that solves all of our problems. Ah, look at that. Now I have an OSPF neighbor relationship. Ah, I just got a neighbor relationship with router 2, who is the guy I was trying to ping from in the first place, and router 4. So now can I do my ping from router 2 again? Does router 2 now have the route? Show IP route 3331. Look at that. He's got a route. And the ping is successful. Now in this particular example, we started out by realizing that we had problems on both switch 3 and switch 2. Neither one of them had an OSPF relationship with router 4. And we just figured out the problem on switch 2. Before we leave this troubleshooting lab, you know, we could have easily just started with switch 3. It was just random that we decided to start with switch 2. But let's say we had started with switch 3 in the first place. Let's see what kind of problem he has so we can fix that. Now, what I would do is, if I've already discovered one problem on one device, I'd say, okay, let me just see if that same problem exists on the other device. Because if it does, that'll save me a lot of time in troubleshooting. You know, why pretend like this didn't happen? Let's learn from this and move on to the other device and see if we can see the same problem there. Okay, so from if you remember from when we built this lab, originally, and we can see here, this connection was in VLAN 4. So since VLAN 5 didn't exist in switch 2, is there a possibility that VLAN 4 does not exist in switch 3? Wouldn't that be sneaky? Let's find out. Show VLAN. VLAN 4 does exist, but wait a second. I think I do see a problem. Notice on switch 3, VLAN 4 exists, but shouldn't there be a port right here? Remember, when a port is an access port in a particular VLAN, it should show up on the right. Like all these ports right now are access ports, switch port mode access, and they're all in VLAN 1. Well, going back to our original diagram, this one, this port right here, port 0/4, was configured as an access port. At least it was back when we built this lab, in VLAN 4. And yet it's not showing up in the output of this. So let's go ahead and take a look at the configuration of that port. Show run interface fast Ethernet 0/4. Aha! Same problem, but in reverse. This time the correct VLAN existed, but the port is in the wrong VLAN. Interface fast Ethernet 0/4. Switch port access VLAN 4. And there we go. Just got my OSPF neighbor relationship up. Show IP route 3331. He now has an OSPF route to that. And so now if we go back to R2, R2 should now have 2 routes to get to 3331. This is clearly the best route. Show IP OSPF database. Summary. And we're looking for a summary LSA. Actually, he only would have received a single summary LSA. If we go back to our diagram here, it would have been router 4, who, when he learned about network X, router 4 would have sent a type 3 summary LSA to his neighbors. And so in router 2's database, he's only going to have a single type 3 summary LSA, the one type 3 summary LSA that was generated from router 4. And then it's up to him to pick whichever path is the best path. So it's okay that he only has one route in his routing table. So in this particular lab, switch 2 and switch 3 had incorrect VLAN to port assignments. On switch 2, his port was in the right VLAN, but the VLAN itself didn't exist. So we had to create it again. On switch 3, the correct VLAN, VLAN 4, did exist, but the port leading to router 4 was not in that VLAN. It was in VLAN 44. That was a mistake. There is no VLAN 44 in this topology. That was incorrect. So that is the solution to this lab. And now we're going to move into troubleshooting lab number 2. If you haven't already done so, please load the OSPF working config back onto the device or devices that you detected the problem in the last troubleshooting lab that you did, and then proceed to load the troubleshooting lab 2 configs on all 7 devices. Same general problem description. R2 cannot ping the loopback 2 of R3. Let's verify that is still a problem. And yes, we cannot ping it. Lab restrictions. All the lab restrictions here are the same as in troubleshooting lab number 1 in the event that you've already done that one. Otherwise, just pause the recording for a moment and read through these before proceeding to troubleshoot. Okay, so let's go through this and try to figure out the problem. So I would start the same way. I would start by checking to see if I have a route to the destination I'm trying to reach. And I do. So I have a route, and this route was learned via fast Ethernet 0/1 from 4444. Okay, then let's go to router 4. He should also have a route since he had something to send to me, but let's just check. Show IP route 3331. Okay, and it looks like he has a static route. And his static route is pointing at 9.34 as the next hop. So if we look at our topology diagram just to see where that is, 9.34, if you've been following along in the monster lab that we built, is the interface on router 3's serial 000.134. Okay, so it looks like from router 2, if we're going to ping 3331, router 2 does have an OSPF route that gets those packets to router 4, and then router 4 has a static route which gets those packets to router 3. So apparently the problem is not that the ping is not getting there. It is getting there. Apparently something's wrong in the reply to the ping. So now let's troubleshoot this in the reverse direction. We know that if router 2 is sending the pings out this interface, that he's going to use the address of 190.190.9.27 as a source. So let's see if router 3 has a route back to this network right here, network F. This looks problematic. Whole bunch of OSPF neighbor relationships are down. Show IP route 190.190.9.27. That's where the pings would have initiated from. Subnet not in table. Okay, so now we've identified what the problem is. The problem is R3 can't reply to those pings because he doesn't know where to reply to. Okay, well, we saw before on the, if we look at the topology diagram here again, that clearly there was no OSPF relationship between router 4 and router 3. Well, actually, we don't know that. All we know is that router 4 had a static route pointing here to router 3. Router 4 and router 3 could very well intend to have an OSPF relationship, and maybe they do, but a static route has a lower administrative distance than an OSPF route. But the fact that router 3 has no route tells me that if there was supposed to be an OSPF relationship between 3 and 4, it doesn't exist. Not only that, but let's say theoretically that this whole link went down, subnet H went down. We know from the lab that we previously built that there should be an OSPF relationship between router 3 and router 1. And so even if network H is down, router 1 should then be able to route those packets across the PPP connection to get them back. But we see here that router 3 doesn't have any indication of subnet F. That route doesn't exist in his table. So let's check his OSPF neighbor relationships. Because we know from the previous lab that he should have 3 neighbor relationships. He should have a neighbor relationship with router 4 across network H. He should have a neighbor relationship with router 1 across network H. And he should have a neighbor relationship with router 1 across network J. Does he have any of those? No, he does not. So his point-to-point neighbor relationship doesn't even show up at all. That was the one on serial 000.132. That's not even in here. The ones on serial 000.134 are in the attempt state. And if you remember, the reason why we see this is because that is a non-broadcast multi-access frame relay cloud. And in order to get OSPF working across that cloud, we had to statically configure our neighbor statements. So he knows about these neighbors because I've told him to talk to those neighbors. He's got neighbor commands. But the attempt state means I'm trying to talk to that neighbor and I'm not getting anything back. Okay, so really we've got 2 general problems in this case that we need to solve. Problem number one is what's going on here with router 3 across the frame relay cloud? How come he doesn't have a neighbor relationship with router 4 and router 1? Second problem is what happened to his point-to-point relationship with router 1 across subnet J? So it doesn't really matter which one we start troubleshooting first. I'm just going to start troubleshooting the frame relay connection on network H and see if we can figure out why he doesn't have that. Okay, so step number one, let's check and see if OSPF has been activated correctly on all the interfaces it's supposed to. Show IP OSPF interface brief. Okay, so it is active on subnet H, and it is active on the point-to-point link on subnet J, so it's not a missing network statement. Okay, now let's move over to router 4 and see if he has OSPF correctly configured on subnet H. Show IP OSPF interface. Oop, I forgot the word brief. All right, here is subnet 1/0, and he does, just the fact that showing up in this output means that we have a network statement covering that. It's in area 1. If we scroll up on router 3, he also had it in area 1. So our network statements are correct on both these routers. They are in the correct area, so that's good. All right, so what else could cause this OSPF neighbor relationship to fail? Well, let's see here. Maybe it's an access list problem. So let's take a look. Show run interface serial 1/0. All right, on router 4, don't see any access lists on here. So there's no reason why that would happen. What about on router 3 side? Show run interface serial 000.134. Okay, same thing. Don't see any access lists here. All right, so at this point, it's time to line these two guys up next to each other and see if we can spot any differences in their configurations. Okay, so on this guy, we've already got interface serial 000. Let's now go into router 4. Show run interface serial 1/0. Okay, some basic things. Are they both in the same subnet? 9.33, 9.34, the mask is the same. That looks good. Okay, what else? I think I spot a problem here. IP OSPF authentication message dash digest. They're doing authentication, but it's mismatched. One side is doing message digest MD5 authentication. The other side is doing plain text authentication. They're not going to form a neighbor relationship if that's the case. So we know from the Monster Lab that they were both supposed to be doing message digest. Let's see if that causes any change. Now, across frame relay, changes don't take effect immediately. Sometimes it takes a while. Show IP OSPF. There we go. We are in the full state. Okay, now that's not going to override the static route on R4 because a static route has a lower administrative distance. But let's see if, even though R4 has a static route, he now should have received an LSA about this network. So let's see if he in turn, as the area border router, went ahead and did his job of creating a type 3 summary LSA and sending it into here. So let's see if router 2 now has a route to the 333 network. And he does. And now our ping is successful. Now remember, we had two problems in this. If we go back, one problem was that router 3 had no OSPF relationships across network H, and that has just been fixed. The other problem was that router 3 didn't have any OSPF relationship across the point-to-point cloud. And we probably want to fix that as well, because if network H goes down, we want that point-to-point cloud to come up as a redundant or alternative path. So, like I mentioned in the first troubleshooting lab, once we identify a problem, let's just see if that same problem is causing this issue. So in this particular case, the problem between router 3 and router 4 was incorrect authentication type. The type was mismatched. All right, so while we're here, let's now go into router 1. And let's compare them side by side. So router 1, show interface, show run, interface serial 1/0.132. That's the frame relay point-to-point connection. Show run, interface serial 000.132. Oh, not router 4. You want router 3. And yes, it is. Plain text authentication on router 3, message digest on router 1. And there we go. Now the OSPF relationship comes up between router 1 and router 3. And he has all 3 neighbors that he's supposed to have. So in summary, incorrect OSPF authentication type between R3 and its neighbors. We need to reconfigure it back to the type of message digest on router 3. Okay, welcome back to CCNA Troubleshooting Lab number 3. If you are recreating this on Eine's rack rental equipment, please make sure that you load the OSPF working configs on all of your devices. If this is the first lab you're starting with, load it on all of your devices, and then load Troubleshooting